All right, I had somebody ask me about a certain problem where you have to factor and break up the denominator, and it's something called partial fraction decomposition. And it's a really beautiful idea, actually. So we'll look at an example from our review problem. So we're looking at this uh, integral here, and the tricky thing is a u substitution doesn't work. There's not really integration by parts that's going to work here either. And so you have to try to break up the denominator. And so the first thing to notice is that the denominator factors. And so I'm going to do some work over here on the side. The denominator factors to be, let's see, 2x and times x makes 2x squared. The only way to get 2 is 1 times 2. I need a 2 over here to get 4x minus 1x. So this is how it factors here. I kind of just narrated what my thought process is, where I'm trying to match up the x squareds, the x's, and the constants. And that same idea of matching up is what I'm going to use to break apart the two fractions here. What I want to know is what over 2x minus 1 and what over x plus 2 adds up to 5x over the whole denominator. So I can find a common denominator by just copying and pasting the missing factor like this. So I'm going to multiply by x plus 2 on the top and the bottom. So I have a times x plus 2. And then similarly, I'll just copy and paste this denominator here and here. So I have b times 2x minus 1. And this is all over. Now they have the common denominator of 2x minus 1 times x plus 2. And my goal is to make this decomposed set of fractions equal to the original one. But we know that the denominators are equal, so we don't need to worry about them. All we really need to make sure is that the numerators are equal. So this comes out to be actually a little system of equations. We have 5x equals ax plus 2a plus 2bx minus 2b. I just distributed it out. The really nice thing here is that the x's need to equal each other. So 5x needs to equal ax plus 2bx. And the constants need to equal each other. So there's a secret 0 right here. And 0 needs to be equal to 2a minus 2b. So what that means is you have a system of equations. 5 equals a plus 2b, and 0 equals 2a minus 2b. I think I distributed everything out correctly. So assuming I haven't made a simple algebra error here, I'm just going to add those equations together. So I get 5 equals 3a. So a is 3/5. And then if I substitute that back into the bottom equation here, which is equivalent to saying 2b equals 2a, then that would mean that b also equals 3/5. I feel like I did something silly wrong here. Did I factor it correctly? Yeah. Did I do my common denominators correctly? Yeah. Oh, I see what I did wrong. Excuse me. So here, this shouldn't say minus 2b, because if I distribute b, I get minus just 1b. There we go. Okay, let's fix it. Let's fix it. Apologies. You got to see me make a mistake. That's good. It's good to see me make mistakes. All right, let's fix it. I just had a hunch that the A and the B values weren't going to be the same because one of them has a single x, the other one has two x's. It just didn't feel right. So let's try to rewrite this out and see if we can fix it. we still know that 0 equals 2a minus 1b. There we go. All right, let's double this and then add them together. I doubled it so they both have 2b. So now that means 5 equals 5a, a equals 1. Substituting that in would tell me that b is equal to 2. If I just use this equation right here, you can see why b has to equal 2. So my original integrand then is actually, I don't need to write the 5 anymore. It's actually equal to the a I just found, 1 over 2x minus 1, and the b I just found, 2 over x plus 2. Each of those is just a natural log when you take its integral. This one is 1/2 times the natural log of the absolute value of 2x minus 1. The 1/2 comes from the fact that the derivative of the inside function is 2. So I did like a mini u substitution there. And then this is 2 times the natural log of x plus 2. So that's the antiderivative. So then we plug in the 1 and the 5 and see what happens. So when we plug in 5, we get 1/2 times the natural log of 2 times 5 minus 1, which is 9. When we plug in the 5 into the other part, we get 5 plus 2, which is 7. We're going to subtract what happens when we plug in the bottom value, 1. So we have 1/2 times the natural log of 2 times 1 minus 1, which is 1, plus 2 times the natural log of 3. Natural log of 1 is 0, so let's get rid of that guy. So then I can express this by moving the coefficient to be the power on each of those. We can get natural log of the square root of 9 plus natural log of 49 minus natural log of 9. And then using powers of logs, we can make that into natural log of 3 times 49 over 9, or natural log of 49 thirds. And so there you go. So please comment or ask questions if I made any mistakes that I didn't catch, or if you have anything that I could